So I'm here to tell you about TypeScript. And before we get started, maybe let me tell you why I'm talking about TypeScript, because I don't actually work on TypeScript. I only work with TypeScript. So I'm a senior staff engineer at Slack. I build primarily the desktop apps. Real quick, how many of you are using Slack? Nice. That makes me feel good. Thank you very much. If you have any concerns about Slack, come talk to me after. So I primarily built the desktop apps, and we ended up porting the Slack desktop app over to TypeScript about a year ago, a little bit more than a year ago. And before I got started with TypeScript, I was working at Microsoft as an open source engineer, and I was very strictly against the idea of anyone trying to write JavaScript without JavaScript. I was pretty convinced that if you want to build something in JavaScript, you should probably use JavaScript, because that's what the machine is going to be executing. You should be, writing the thing you're going to run. Wasn't really a big fan of anyone trying to redefine what JavaScript should be like. And I underwent this transformation from someone who was very strictly against TypeScript to someone who's a big fan. And this talk is very much the how did I end up here? How did we end up loving TypeScript so much? And I want to motivate that a little bit before we get started and talk a little bit about why TypeScript in the first place. Why do you want to improve JavaScript? And the reason I think I want to motivate this talk is because I don't think people actually realize how popular JavaScript and HTML is. There's a lot of JavaScript that you're running on your machine that you might not know about. And this is one of my favorite examples. If you play Battlefield 1, the user interface, the little ammunition counter and the map and all these things are a React app. They're written in HTML5, MobX, and React and TypeScript. That is how Battlefield 1 displays all the little user interface. So that's one area where I think many people don't really realize JavaScript is running. There's other examples. If you have a Windows machine and you're running the NVIDIA GeForce experience, there's a Node.js server running every single time you start your machine. And that Node.js service is used to communicate between applications and your GPU. And then, of course, we have all the Electron applications. We started with Electron a few years ago, and these days there's tons of them. Slack is one of them. But if you're using applications like Visual Studio Code, Atom, Spotify, you're probably running JavaScript on your machine. And the reason this is important is because we're breaking out of the attempt to just display a document, right? We're building actual applications here. And in my world, whenever I make a mistake in JavaScript, the end result isn't a console error statement. The end result is usually that we crash, because we interact with C++, we interact with native code. It is crucial that the code that I write is structurally sound. It is important that when a method expects a string, there's actually a string. This is really important, and it's equally important for all the other applications. It's important for Battlefield 1, it's important for the NVIDIA GeForce experience, and it's probably important for the things that you're writing, right? Like, none of us are building things thinking that, oh, errors are fine. We usually actually want to write code that is correct. And now that we're here, people have primarily developed documentation ways of figuring this whole world out, right? Like, how do you deal with the fact that you want to have structurally sound JavaScript? And that's sort of how I did it in the beginning. You start with documentation, right? Like, the first thing people do is that they document their methods, they document the input, they document the output. And I'm sure many of us have seen this. Sorry. Many of us have seen this, right? This is normal JS doc, and this is how I used to organize my code, but it has a bunch of major downsides. And the biggest one is that you got to trust that whoever wrote this documentation at the top didn't lie to you. And developers tend to lie, right? Like, someone goes in, makes a change, didn't update documentation. So if you really want to know how a method works, the best method you have is to actually go and read the source code. Now, Slack, for instance, we have something around the tune of roughly 10,000 JavaScript files. You can't read it all. It's not possible. There's no way to do that, right? If you want to read the whole source code every single time you've got to change anything, it's inefficient. It's going to take a long time, and you're probably going to end up making mistakes anyway, right? Even if you understand the whole code, if you have a promise that is being handled by 50 different files, at some point something's going to get lost. And TypeScript really helps here. It has a few properties that I like. The first one is that it's a superset of JavaScript. which means all JavaScript is valid TypeScript. This is really important. I'm going to talk about that in a bit, but I'm going to say it again because it's probably the most important property. JavaScript is valid TypeScript. There's no JavaScript that isn't legal TypeScript. The other thing is that we really wanted something that doesn't modify the code at runtime, right? If you think about something like prop types or other approaches that people have taken, there's nothing running on the machine that the user has that checks our code. We just wanted to know before we commit code that it's valid. And the other three things we were worrying about were editor support. We built Slack for all operating systems. We have developers in working all operating systems. We needed something that works really well in whatever editor you choose. Developers tend to fight over which editor is the best. I tend to use Visual Studio Code, but it doesn't matter which one you use. TypeScript will probably support it. That's the good news. And the other thing we needed was excellent integration with NPM. Like any other Node.js app, we use a decent amount of NPM modules, and TypeScript works really well, not only because there's a lot of typings available for whatever module you have, but also because if typings are not available, TypeScript handles that really well. It's fairly easy for you to say, OK, I don't have types for this module. Let's just pretend it's JavaScript and move on, right? And that's really important for us. And lastly, and this is the only part that I think is obvious, is that TypeScript has types. Not to the surprise of anyone. This should be straightforward. But for all of those reasons, we ended up with TypeScript. That's why we picked it. And with that being said, I think the easiest way to actually transfer why I like TypeScript so much is to actually show you. So that's what we're going to do. We're just going to go and look at it, which I think is the easiest thing. Is that big enough for the people in the back? Can people just give me a nod or a no? Yes, thank you very much. Cool. So this is some JavaScript, right? And nothing special is going on here. But if I wanted to now use this method, my editor does sort of know that sort people exists. But that's about it, right? There's no other information available. And if I want to call it with a number, my editor is fine. Like, there's nothing here that will catch this. It's a very easy mistake to make, right? I just gave it a wrong input. If I commit this now, the next time it's going to crash is going to be on your machine. There's nothing between here and now, here and then, that is going to catch this mistake. This is just going to go straight to production, right? There's really, really nothing here that fixes that. So we at Slack wanted to fix that. And one thing that is really interesting is that we obviously didn't have time to rewrite 10,000 files, right? We have bugs to fix, features to ship. There's all kinds of things people want. I already came here. 5 people already asked for dark mode, right? There's like a lot of things that people really want. So we can't just stop and rewrite the whole app. That doesn't really work. And because JavaScript is a superset, you can start really easy. You can start by renaming the file to TypeScript. And at the beginning, that's all you need to do. That's it, right? You could just step away now and be like, all right, lunchtime. That's it. Because JavaScript is valid TypeScript, I can check this in. It's going to run. It's going to work fine. But one thing we will notice is that there's already one little mistake that was caught, right? Right here, TypeScript goes, hey, you try to call this sort method thing, this sort people method with a 5. We see that up here we're expecting an array. Because the method is written with an array, you probably didn't want the 5, right? So that's immediately one mistake that was got. And that is what happened at Slack too. We didn't change a single line of code. We just had the TypeScript compiler running over the code. And without any additional changes, TypeScript found a few bugs. And the bugs that it found weren't super obvious. They weren't the type of bugs that happen all the time. They were only happening if certain conditions were true, and we were receiving some code from native, and then it went back to the web app, to the server, came down, and now, typical mistakes are name ID was suddenly spelled as name ID, right? TypeScript finds these things if they're given through 50 different promises. So that's what happened for us too. But now that we have fixed this mistake, let's look at some of the other things that immediately happen without us changing any code. Because TypeScript knows that input is an array, it also knows what result is. So if I start typing result dot, I immediately get autocompletion for every single method and property that is available on this array. And by the way, this is not Visual Studio Code. This is TypeScript. You can get the same autocompletion in Atom or a Vim or whatever editor you use This is the language server. It doesn't matter which editor you use. You get the same autocompletion wherever you are. And these are all the things that are available. And if I now want to call, I don't know, find index, right? I get documentation. I can see how this method is supposed to be called. And interestingly enough, if I want to, I can go and check the actual definition for this out. So right here, this is the definition for find index, right? This is the type definition. And one thing I want to tell you right now is that this file has about 500 lines. And this is just for the new array methods, just the new array methods. All of the DOM, all of the JavaScript APIs are about 40,000 lines of code that you're supposed to have in your head right now, right? Like I'm supposed to be, if you work in web development, I should be able to walk up to you and be like, find index, how do you call it, go. Because there's like nothing that will help you. You're supposed to know off the top of your head how to call all these methods, not just for array, but for anything else. And if you don't know, and if you do not Google every single method you ever call and look at the documentation for all browsers, you're probably approving or committing code that is wrong. There's nothing that will find this. You're just supposed to know it. And I don't know about you, but I never memorized the whole array thing. I Google the dumbest stuff, right? Like how to fill an array. I looked it up every single time. And with TypeScript, I don't have to. It's fine that I don't know what all the array methods are, because TypeScript does. And that's really quite powerful, right? But these are just the benefits you get when you don't do anything. This is not really TypeScript that we're doing here. Let's actually run TypeScript. So this is my terminal right here. And TSC is the TypeScript compiler. And I'm going to run it. I'm going to say initialize TypeScript. So initializing TypeScript, as you can see, does really only one thing. And that's over here. It now created a tsconfig file, which doesn't really do much, right? There's nothing super exciting in here. We're specifying that we want the output to be ES5, which is a slightly older version of JavaScript. And we're specifying some Node.js interrupt stuff. But most of the options here are commented out and sort of for later, whenever you want to do them. And now that we have that, we can go ahead and actually run our code side by side. In this case, I started compilation on watch mode. And we can see that we already have a few errors here, which I'm going to come to later and fix them there. For now, let's just open our code side by side. Here we are, TypeScript on the left and JavaScript on the right. There's one thing I want to point out here, which is that, as you can see, the code on the right looks like normal JavaScript. I don't know if you ever used any other compilers or CoffeeScript or some of the other JavaScript versions. It is really important to me that I, as a human developer, can look at this code and understand it. This is roughly the JavaScript I would have written. There's nothing added here. There's nothing crazy going on. This is just normal JavaScript. And that's quite powerful. Now, let's actually start typing things. So in this case, we have an input of, who knows? It's just an array. And I'm specifying this name thing here. And TypeScript knows that this is not typed. So let's go and do the actual typing information. Let's go and start working on actual types. So I'm going to specify my interface here. I'm going to say interface person. I'm going to say we have a string, and we have an age, number, good enough. And then in here, up here, I can say input is an array that is filled with person. And now things get really interesting. This is one of my favorite features. Because I defined what kind of information is going on here, TypeScript can follow your code and see what is going on. So let's read this code together, right? We're slicing the result, which is now still an array of person, and then we're sorting it by name. And because TypeScript knows what is going on, it can tell that .name is a string right here. It knows that A is of type person and name is a string. And because that is the case, it knows that I misspelled local compare. And we've now been looking at this code for 15 minutes. How many of you have noticed that I misspelled it? There was one person. Everyone else would have approved this commit. Would have been, yeah, looks right. And that would have crashed in code. And here's the really funny part. It wouldn't have crashed on my machine, but it would have crashed on a user's machine, which is really annoying. So because this is TypeScript, don't really need anything. It will fix it for me, and now my code is correct again, right? And the other thing I want to say is if I save this file, over here, nothing changed. We did fix the misspelling, but none of the types actually end up in my final code. If I use TypeScript as a developer, the user doesn't get any additional code, the file isn't bigger, nothing has really changed. This is just straight up JavaScript. But interestingly enough, if I want to make things, if I want to have things a little bit more compiled, TypeScript can really help out. I said that all JavaScript is valid TypeScript, and that includes modern JavaScript. If you use an older JavaScript as the output, TypeScript will go ahead and help you. You can already see that I'm using a default here, right? This is a default assignment, where if you don't pass something in, it will be an empty array. TypeScript compiles it down to this, which is exactly the TypeScript I would have written. But you can do that with more interesting features too, or you can disable it depending on how you feel. So if we say, you know what, I'm actually fine with ES 2017, like this, then it will just go back to the old thing, right? And the same thing is true for the arrow method. Like, notice how it's using an arrow here. If I go back to ES5, if I go back to ES5 and stare at it for a second and maybe restart the compiler, there we go, then it will go back to a function, right? And that doesn't just work for the little stuff, it works for classes too. So one thing you could do is that you say, actually, I have this interface person here, but also I want a class person. Person, class. Actually, we'll just do this. Sorry. We'll just go ahead and call this iPerson, class person. You know, maybe that's good enough. Now I have a class here. If I save this right here, again, TypeScript writes JavaScript for me that looks like the JavaScript I would have written. Nothing magic. There's not like 3,000 lines of boilerplate. And I came across this other library the other day that looked really cool. It was some observable React stuff. But the hello world thing was 3 lines of code in the source file, and it was 20,000 lines of code in the other file. Because it redefined what a function is, it redefined async, it redefined await. TypeScript doesn't do any of this. I can just ship this, exactly the file that you're seeing here. And that's quite powerful. That's really cool. So that's it for the demo. There's a lot more features in TypeScript. This is literally just the hello world. But this is maybe the biggest feature, how quickly you can change a file without going any further. So let's go back to this presentation here and talk a little bit about how that actually ended up working out for Slack. So as I already said, we didn't really have time to port the whole application, so we started by just changing files. And the way we work at Slack is that we iterate over features a lot, right? We really want to deliver a polished experience. And usually by the time we're done writing a feature, we might as well start rewriting it, which happens a lot. We touch the same files over and over again. So we thought, OK, we're going to turn on the compiler. We're going to do nothing else. We're just going to turn on the compiler, and then we're going to start writing new files in TypeScript, just new files, and we're going to leave the old files alone. And that worked out quite all right. We immediately found all these little errors. But one thing that happened very quickly is that every single time we had to call a method from an old JavaScript file, or every single time we had to go back to an old JavaScript files, working with just JavaScript felt a little icky, right? There was like a little part of us that was like, ugh, this is kind of gross. I don't really know how this method works. And one thing that I think I underestimated is the power of autocomplete in an editor. And I'm an old native developer. I worked a lot with C++ and C#. And if any of you have used Java or something before, you're going to go, well, duh. Obviously, autocomplete is amazing because you've already had it in Visual Studio and Eclipse. But most JavaScript developers don't have autocomplete, right? They have a reference to all the other variables that are in the file, but they don't have anything in the editor that tells them your code doesn't have typos, which is really powerful. Being able to make a PR and knowing that at least I didn't make a typo is so powerful. It really changes how quickly and with how much confidence you can commit things. So we wanted to give ourselves time, and as I said, just new files. But because changing files is so easy, right? If you want to, you can just rename the file and you're done. What happened very quickly is that every single time someone had to touch a file, they were just like, ugh, I'm just going to take the 5 minutes and port this over to TypeScript. That's just what I'm going to do. It's going to be quick. So spoiler alert, instead of years, it took us about half a year to port the whole app over to TypeScript. And that happened without any push. There was never a point where we were like, all right, this week we're just going to port things over to TypeScript. Didn't happen. It happened entirely organically. People were just super interested in actually working with type files. And this whole notion of committing with confidence is really powerful. As I already said, it really empowers your engineers. It makes them sleep better at night. I'm on call for the desktop app 24/7. One of my biggest fears is that I wake up at night and I learn that you can't use Slack because I made a mistake. And knowing that I didn't make a mistake really lets me sleep better at night. It's very powerful. But let's talk a little bit about the downsides. There's actual things that I dislike about TypeScript. This isn't just a big sales pitch. And I don't have a solution for them. I don't really think this is anything you can fix. This is just something you buy with a bag. And this is maybe the biggest downside of using something like TypeScript. We're a team of mostly native developers, meaning that we know types pretty well, right? Functions like union types, declarative types, type inference, interfaces. All those things come pretty natural to us, and they come fairly natural to anyone who's already worked with a type language before, something like C#, Java, God knows what. But if you hire front-end engineers today, many of them have never used anything that is typed. They may have used Ruby, Python, JavaScript, that's it, right? And once you start using all of TypeScript, it can look pretty daunting. So I try to find the most scary amount of TypeScript that we have at Slack. This is my personal winner. And if you're looking at this and you're like, what the hell is going on? It takes everyone about 5 minutes to start this method and be like, what? Right? It's pretty normal. So every single time we onboard a new engineer, my intern is going to start on Monday, for instance. I'm probably going to have to sit these people down, and before they can start working on the Slack app, they have to go through and get a crash course in what are interfaces, what is type inference. So you can't really see the cursor here, but there's a bunch of really cool stuff going on where we automatically infer that something has been proxified. We basically throw in a bunch of types and outcome types. This is a dynamic type declaration. And as of now, TypeScript is Turing complete. TypeScript has become its own coding language, which is pretty impressive. But yeah, so that's the biggest downside. The biggest downside is that it might be complicated. Right? If you use all of TypeScript, if you use it to its fullest power, you might end up having a little bit of onboarding difficulty. But that's about it. It is 15. We're virtually out of time. So my recommendation for you is that if you write JavaScript that shouldn't have any errors, you should probably use TypeScript. That is how general I am these days. But you should weigh it against how difficult should it be to work in these files. So in my case, anything that is big, and I know only people that get paid to work on this thing end up working on it, we use TypeScript. So obviously Slack uses TypeScript. Electron is now porting their files over to TypeScript. We've started with that effort. But there's a lot of little modules that I have written that are on NPM. I have about 1,000 modules on NPM. A lot of those are still in JavaScript because I want to make sure that anyone can actually contribute to that code. And if it's simple enough, right, if my module has only 100 lines of code, I sometimes go, JavaScript is fine. I don't really need to compile all of this, right? So it's like a balance act between how secure do you want your code to be and how easy do you want it to be to work with that code. If you have any questions about TypeScript or not TypeScript, you can also talk to me about anything else. Please come find me after or find me on Twitter or wherever. And that being said, thank you so much for being here.